So now let's practice two hypothesis examples of statistical testing, or inference testing, or statistical inference. Those are actually mean the same thing. So let's look at this claim, this argument. So going back to the claim, we are to verify if wages, if the estimation of population wages at 6.5, whether this is an acceptable claim. So what we are going to do is first, you go back to the hypothesis testing. The hypothesis that you are generating is the H naught. The H naught is the wage equals to 6.5, and the alternative is that the wage is not. Okay, right here, 6.5. So that's the null hypothesis. And here, what we need is we need to figure out, we need to find those statistics. Okay, so the shortcut is to find by finding the summaritive statistics. So what we do is we go to data analysis, and we go to descriptive statistics. We have input range as A, and it has the label as the first row. Okay, and we have a new worksheet, and we name it as salary wage. And we have to look at the summaritive statistics. So let's go. So this is the wage. Then we are going to apply this calculation, this series of calculation, which is here. We need to work out the t-stats. But before doing that, we need to clarify. So let's put here, H naught is wage equal to 6.5. That is the population mean. Okay, and your sample mean is 5.9. So here, numerator is equals to, let me put 6.5 in the second cell. Later on, it's easier for me to calculate. Okay, so the numerator is the numerator of t-stat. Okay. The numerator of t-stat is the sample mean minus your guess, which is E2. Okay, that's this. And your standard error is this. Then we can calculate t-stat, which is sample mean minus population, estimated population value, which is calculated here. And the t-stat then the numerator should be divided by your standard error, which is this over your standard error. So that's minus 3.65. So with this bearing in mind, okay, you can already make the decision to reject the null hypothesis, because here, when the hypothesis value is roughly 2 times lower than the actual sample mean, right? It's already only 5% of chance that something lower than that will happen. And here, your case is minus 3.65, which falls under the 5% of chance. Then here, it is smaller than minus 1.95, which tells you we should reject the null. Okay, which means the population wage should be statistically different from the guess, from the hypothesis, which is 6.5. Namely, we should believe the wage being, namely, we should believe that the wage overall is statistically different from 6.5. Okay, so that's one method. And then let's look at p-value. Okay, so here we're going to use the t-distribution. So what are we doing is actually we are seeing, hey, what is the area? What is the area that is the tail when t-stat actually equals to 3.65? Okay, what is the shaded area? So what we do is we use t-distribution. Okay, so the first one is x, that is here, and then degree of freedom, that is the count minus 1 for this case, when there is only one t-stat to look at. Okay, and then it is 2 tails. The result is so much different, so much smaller than 0.05, right? So again, we should reject the null and consider the sample mean reflects a much different, consider this sample reflects a much different population wage than hypothesized, which is 6.5. Okay, and here to maintain consistency, here you can see minus 3.5 is smaller than 1.96. Okay, what we actually are looking at is how much times the numerator is compared to the standard error, to the divergence, right? So it's actually more than 2 times. So here we can also, what we normally do is we are looking at absolute value. Okay, which is abs means absolute value, and that is greater than 1.96. And that's when we should reject the null hypothesis. So that's question 1 here about the wage. Let's look at question 2, which is the work experience. So now we are looking at the work experience, and the first thing that we need to do is hypothesis. So here in this case, H naught is year population that you are estimated equal to 16. And the alternative hypothesis is year of the population that is not equal to 60. Okay, so then we're talking about years. Here I should unhide, that's somewhere in here. Years of experience, right? Years of experience. Let's do experience. EXP means experience. Okay, so that is actually this one. So the next step, what we are going to do is to find the summative data. So now instead of looking at A column, we're looking at C column. Okay, and here we have experience as the output. So this is the result of experience. And here we are guessing H0 is experience population equal to 16. And the first thing that we do is numerator of t-stat that equals to the sample minus, let's go back to this. That is here. The sample minus the hypothesis value. So what is sample? Sample is here. So that's the sample minus the hypothesis value, which is F2. Okay, and here the standard error is the row underneath. So we can calculate t-stat, which is the numerator over the denominator, which is standard error, 1.71. So that is smaller than 1.96. So we cannot reject the null. Okay, so we cannot reject the null. So the conclusion is that this sample reflects that the population, the hypothesized population is not much different, not significantly different from the statistics reflected, the summary statistics of the sample. So based on the sample, we should not consider that experience equal to 16 as a wild estimate of the population experience status. Okay, we cannot reject the null because this sample, this testing reveals that the hypothesis population is not statistically different from the summary statistic of the sample. So based on the sample, we should not consider that the previous guess was wrong. Okay, but can we say that the previous guess is correct for sure? Here comes the other thing. We should not do that. Okay, there are two things to note. We can either reject the null or cannot reject the null. It's illegal to say that we accept the null. What is the case that we accept the null? We are saying the population experience is exactly 16 years even. The chance of that is almost zero. Okay, the chance that this statement is just true, that the average population experience is exactly 16.00 is nothing, is non-existent. Okay, so that's the first one. And also rejected the null meaning statistically significant, and here the answer is it is statistically insignificant. And we can also do this by looking at p-value. The p-value is t-distribution of the t-stat, and looking at by considering the degree of freedom, and also tells it's a two tails. So it's 0.95, which is much greater than 0.05, which is the same conclusion. cannot reject the null, namely statistically insignificant. Okay, so those are the two examples.